SANS at Mike Talk, SEC510, Multicloud Security Assessment and Defense. My name is Jessica Gellis of SANS, and today's featured speakers are Eric Johnson and Brandon Evans, who will be moderating today's webcast. If during the webcast you have any questions for our presenters, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that a copy of this webcast is being recorded, and a copy of the slides and recording of this webcast will be made available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Brandon.
Thanks, Jessica. So thank you so much for taking the time to attend this SANS at Mike Talk. My name is Brandon Evans. I'm here with Eric Johnson, and we're going to be talking to you about SEC510 Multi-Cloud Security Assessment and Defense, a class that we've been working on for quite some time. And if you're interested in taking the first ever instance of this class starting on August 17th, take a look at the URL at the bottom of the first slide. We are still open for registrants for our first beta, and it will be at 50% the price point of the normal class as it is a beta. So hopefully by the end of the presentation, I will and Eric will have convinced you that this is a class worth your time. So in this presentation, we are going to go over the motivation of this new course, provide a condensed version of one of our sections, demonstrate the lab environment, and discuss some of the other subjects in our syllabus. So first, the motivation. What is multi-cloud? Why do you need to care about it? And why are the majority of cloud-based organizations adopting it? Before we can discuss multi-cloud, we need to understand how the public cloud provider landscape has evolved over time. On the left, we have Gartner's Magic Quadrant for Cloud Infrastructure as a Service from 2014. On the right, we have the same chart from 2019. In these past 5 years, two major things have changed. One, the market has consolidated to a much smaller set of providers, and two, the gap between the top three providers has shrunk dramatically. Amazon Web Services, or AWS, is still the clear leader. However, Microsoft's Azure has proven itself to be a viable alternative, as demonstrated by it winning the US Department of Defense's $10 billion JEDI contract at the end of 2019. Google, although lagging behind the other two providers, is quickly growing in adoption. 2019 marks the first year they were featured in the leaders portion of the quadrant. In 2018, they were still considered a visionary. And there are many reasons for Azure and GCP's growth, including their compelling price point and unique features. Additionally, the way we use the cloud providers has also changed. Organizations are not necessarily using a single cloud provider anymore. Forrester surveyed 727 cloud decision makers globally and found that 86% of respondents identified themselves as multi-cloud. And in the context of that survey, that meant using multiple public and private clouds for different application workloads. This graph shows how many of these organizations use each provider. If you add up all of the percentages, you'll find the number adds up to much more than 100%. This is because many organizations use multiple providers. This allows them to leverage the best services for the task at hand to avoid vendor lock-in and to fail over to different cloud providers in a disaster recovery scenario. Now, multi-cloud might be appealing for the business, but for security, it can be a very serious challenge. It's more than hard enough to secure one cloud provider. It becomes much harder to secure two or more of them. This is why it is critical for today's security professionals to learn how to perform a multi-cloud security assessment. This is where you analyze each of the providers used by your organization for security vulnerabilities and weaknesses. Although each cloud provider has impressive security capabilities, all too often, cloud services are insecure by default. They do this in order to help the customer get their systems up and running as quickly as possible. And they'll do this even if it means launching insecure infrastructure. It is our part of the shared responsibility model to change these defaults when necessary to protect our organization's assets. Through the lessons learned in this course, You will learn how to analyze the configurations of each cloud provider, and through this knowledge, you can create internal policies and standards for your organization's usage of the cloud. Through this, you can support your business by enabling the product development organization to move safer and faster. We model much of our advice off of the Center for Internet Security's benchmarks for the big three cloud providers, AWS, Azure, and the Google Cloud Platform. Each provides step-by-step implementation and assessment features for hardening your cloud account. Topics covered include identity and access management, networking, monitoring, and logging. SEC510 seeks to both explain the advice provided by the CIS benchmarks in a more digestible fashion, as well as prescribe additional solutions for the large portions of the cloud service catalog not covered by the benchmarks. These cloud providers are constantly evolving, and it can be very hard for security to keep up. As Eric and I both come from a developer background, we have stayed engaged in that world, and we're still playing around with the cutting-edge tools that your company's developers are introducing into your technical stack every day. And I'm going to tell you right now, you won't believe the things that we've learned about these cloud providers, both in our day jobs and while creating the SEC510 lab environment. In security, offense informs defense as well. In order to emphasize protections that would prevent the biggest amount of damage to your business, we have also leveraged MITRE's Attack Cloud Matrix. The matrix illustrates how attackers can weaponize your insecure cloud infrastructure for crime and profit. In SEC510, you will learn how attackers steal sensitive data from insecure cloud services, launch botnets that are used to attack various entities from the servers that your company is paying for, and most importantly, how to thwart their evil plans. With that, I'm going to kick it off to Eric to discuss two of the topics we will be covering in this course, IAM and virtual machines. Eric?
Thanks, Brandon. Hopefully the audio came on all right. So what I want to do here is really walk you through one of the core sections that's on the first day of SEC510, where we really look at how identity and access management ties into virtual machines. So let's go ahead and dive into that section, and we'll kind of cover the way that the cloud started. If you think back to 2006 when AWS came out, and maybe fast forward a few years for Azure and a few more years for Google, the one primary offering that we had was just virtual machines. So if you wanted to spin up a database or a firewall or some sort of shared service storage, for example, or a VM, you had one service to do it. So it was very basic, very simple. Your customer responsibility model were in charge of hardening that instance, installing the software, and doing a lot of the maintenance and security that comes along with that. As we push forward and look at what the cloud actually is doing today, it's a lot more complex. You can see that we still have VMs, so we still are running, Apache and Nginx servers, for example, but now you've got to manage load balancer in all of these environments. And that might be forwarding to a cluster of your virtual machines. Those VMs now are just more pass-throughs to other large-scale services like RDS out in Amazon's ecosystem, or Azure SQL, or Google Cloud SQL, or Redis clusters, or Firestore. We've got centralized storage. So you've got all of these managed services now that your virtual machines in the cloud need to authenticate to. So as you really look at how these services are talking to each other, it comes down to that virtual machine and what identity and access management policy is attached to it. So these credentials that are assigned to this VM are really what allow you to talk to a lot of those other services, such as your DynamoDB or your S3 storage bucket or your Azure Key Vault or whatever it is that your system needs to speak to. It boils down to identity and access management. So in the next several slides, what we really want to take a look at is how these virtual machines are being provisioned their credentials. So our next slide has to do with service accounts. And it's a very basic terms, something if you've been working in the Microsoft ecosystem that kind of speaks to us, right? So we're generalizing the implementation for each cloud provider into this more global term service account. But the implementation is a little bit different per provider. And ultimately, what you've got, you've got AWS, you've got instance profiles. You have to know in Azure, you have to maybe go look for managed identity. In GCP, it's called the service account, which is probably the easiest one. All of those implementations have this centralized storage area on the virtual machine called the Cloud Instance Metadata API. And as Brandon mentioned in his opening section, the probability of an attacker locating this, what they're going to red team against, is very high. They know to look for these, and this has been such a ripe target for attackers that the Cloud MITRE attack framework created T1522 specific to these instance metadata APIs. Now there's some information in here that's more benign, right? You've got OS disk information, the host name for the machine, some basic identifiers, and then you get into more interesting things where you can start to enumerate the network interfaces. You can look at the public keys that are associated with this instance. And if you look at the red item on the slide, which is supposed to scare you a little bit, that's if you're a red teamer. That's where you're going to start looking for things. So let's flip to the next slide and we'll take a look at how we can actually communicate with this metadata service. Now, this is a command that we're running locally on a virtual machine, just using a curl command, and we're querying the link local address 169.254, 169.254, and we're looking in that metadata. So this is straight out of Amazon's documentation. It's not really anything crazy new to their ecosystem, but if you're new to the cloud, you may not really know that this is happening. So in this example, we're querying the metadata service and we're just saying, show me the security groups that are attached to this instance. So just a very basic example. If we flip to the next example, this is the Microsoft Azure metadata query. So it looks pretty similar, right? Notice the same IP, 169.254, 169.254, except there's a couple extra things that you should be aware of here. The one in bold, that -H metadata : true, is something additional that Microsoft Azure has had since their default implementation. And that's an extra header intended to prevent some of the red team attacks against this metadata service that we'll cover here a little bit later. The other thing that you'll notice is their API version on the URL. You've got to specify exactly which version you want to query from. And in this example, we're just grabbing the public keys that are associated with this instance. So you can see the response there is our lab environment that Brandon will show you here in a little bit. And you can see, oh yeah, that's an authorized key that's stored on this virtual machine. So if we move forward to the next example, there's Google's. Now Google, you'll notice that's not an IP address, although it does resolve to that same link local endpoint. So you've got metadata.google.internal, and notice again, do you see on line 1, we've got that -H metadata flavor Google. That again is a header that is in their version 1 metadata service that is intended to prevent some of the attacks against these services and stop attackers from exfiltrating data through that service. So let's switch to the next slide, and we'll talk about an example that happened about a year ago. Many of you probably remember July of 2019 when Capital One announced, we had a breach, something went wrong. If you read through the documentation for that, what you found is that the metadata service, what we just walked through, was the central point of attack there. without an issue in that metadata service on an EC2 Amazon server, this attack never really happens. This really isn't anything new. This metadata service has been talked about since Black Hat 2014. Andreas Riancho did a presentation on attacking the metadata service. Researchers at Netflix have talked about this weakness for years, to the point where Will Bingston actually released a credential theft tool that actually looks for metadata tokens being stolen. Scott Piper from Summit Route has talked about this quite a bit. For those of you that follow Rhino Security and a lot of their research, they have mentioned this metadata service over and over again. It really just didn't get the publicity it deserved until July of 2019. So if you look at this example, you've got your regular user on the top of that slide that's making a normal application request. And that request is hitting that EC2 instance, and the application is querying the metadata service internally. If we look at the attacker, they can potentially use an application flaw, such as server-side request forgery, to talk to that metadata service directly. So let's jump to that slide, Brandon. We'll take a look at that metadata interaction and how server-side request forgery can actually enable this. So here's some very basic code. It's a GET request. It takes this URL parameter. You can see that on line 1. And if the attacker in that previous slide can control that value, we can change it from a maybe more benign request to that metadata endpoint. And that GET request on line 4 is going to just come straight back to the attacker. So let's take a look at a couple of examples here on the next slide. What we see here is a standard user interaction. Now, this is an example from our lab environment. Brandon will show this to you here in a few minutes, but we've got this request to nimbus.labs. And notice the file path parameter. That is a parameter pointing to some logo out in an S3 bucket. And the response is going to pull that file down. But the question is, what happens if we change it to something more interesting? Suddenly, hopefully the green changing to red has alarmed you a little bit. But if that isn't enough, notice we're querying 169.254, 169.254 latest, metadata, IAM, security credentials, and we're actually asking the virtual machine to tell us what the name of the service account, the instance profile role is that's running on this instance. And we can start to interrogate that metadata service and find out what these credentials are. So let's push forward and take a look at what the credential query looks like across all of the clouds. And we'll talk about what their tokens are, how those are working a little bit. So starting with AWS. Now this is version 1. This was the version in place in July of 2019 when that breach happened. And you can see it's a very basic request on lines 1 and 2. There's no custom header there. So any server-side request forgery vulnerability can go in, ask for that SEC510-EC2 credentials, and notice what comes back in the response on line 4, 5, and 6. You've got access keys. Now those access keys are valid. They live until the expiration that you see on line 7, which is about 6 hours in Amazon's ecosystem. So if you're an attacker and you steal those, you are free to use those for between 6 or less hours, depends on when you compromise the instance, and you have permissions to that customer's account up to whatever role or policy is attached to that instance when it comes to life, which could be very damaging if you've got an overly permissive instance there. So let's move to the next example. And what we'll see is very quickly, so remember I said July of 2019, on November 19th, version 2, in response to that Capital One breach comes out, that is a much stronger implementation. So notice in step 1, it's now a 2-step process. So you've got to retrieve a token from the metadata service using a put request. And Amazon put a lot of research into that verb that they selected, because the first time I read it, I thought, weird, why did they use a put? It seems like it should be a get. And as it turns out, most open proxies and open firewall implementations that could introduce a server-side request forgery vulnerability, most do not support put requests out of the box. So they selected put to eliminate a large percentage of the misconfiguration SSRF attacks. And then note, you also need a header. You need to give that put request the X AWS EC2 metadata token TTL seconds parameter, and that's going to retrieve a just random token for you that you then need to use in the second request. So notice that is another curl request to the IAM security credentials, and the token you receive from the API token endpoint needs to go in that header to actually retrieve credentials. So a much stronger implementation in version 2 that is relatively new. And as a cloud assessor, Brandon will also walk you through here in a little bit, you need to make sure you're using the right version of this thing. So food for thought as we kind of push forward with this conversation. Azure's is pretty stable. It requires that header on line 3, so it blocks basic server-side request forgery attempts. And then the other interesting thing about Azure's on line 2, so do you see the resource there? It's pointing specifically to storage.azure.com, which is very important to understand when you receive your access token back, which is on line 1. That is a JSON web token. So on the next slide, we've got an example of decoding this token. And notice the audience. On line 2 is the exact resource that we requested. So this token that you receive back from the managed identity service in Azure is scoped to one specific service. If you wanted to go talk to maybe the key vault, for example, you've got to make another request to the managed service identity, and you've got to go grab a different token. So from an attack perspective, this is kind of annoying. You have to grab several tokens and know all of the services you want to talk to in order to start to compromise the customer's account at scale. So you're going to create a lot of noise grabbing a lot of different tokens instead of AWS, for example, where it's good for all of them if the policy allows it. So that's the Azure Managed Identity JWT in a nutshell. Google's is interesting. Now, if you read the Google documentation, they do not mention really at a first pass this version .1 or the V1 beta 1 metadata endpoints at all. So they just say, hey, look, here's version 1, here's what it's look like. But if you read close enough, or if you've been on their email list for a while, they send an email out. I think the last one I saw was a couple of weeks ago that said, hey, we're going to turn these things off in September. And then there was one before that. They were supposed to be shut off in January of this year. But if you spin a VM up right now in GCP, you've actually got 3 different metadata endpoints to pull from. So if you pull from the 0.1 version, notice you're missing that header that prevents SSRF. And you will get an OAuth bearer token back that's similar to AWS, is good for all of the services that the VM is scoped to use, so that are attached to that service account. If we move on to the next slide, this is what their documentation is more open with, right? Here's version 1. This is the one you should use, and it needs the metadata flavor Google header. So there's the differences between the 2 GCP endpoints, and we can kind of push forward and talk about maybe how these things compare to each other. So from a cloud assessor perspective, which one's the best? Which one should you be worried about using? Which one should you be worrying about disabling? If you look at AWS version 1, there's not a lot of positives on version 1 of the metadata service in AWS. So you should be assessing all of your VMs, shutting that thing down, because there's no SSRF protection, there's no token scope. You do not have to authenticate via the REST API. They work with AWS's command line. They don't prevent extraction. If you look at version 2, notice we've got some extra protections. The SSRF protection, the timeout is still 6 hours, still no scoping. You can still use them via the CLI, but they also use a TTL on all requests to the metadata security credentials endpoint, and that TTL is set to 1. So from an attack perspective, when Brandon demos this, what will happen is if you try to extract them off the VM, the TTL immediately gets reduced down to 0, and then that packet's not going to traverse across the wire. So there's your AWS assessment criteria. Azure is actually pretty easy because there's only one option. It has SSRF protection on. The token timeout is 24 hours though, which if you compare them, that's the weakest number on the slide, comparing the 3 different public clouds. And you can't change that. That is a default setting. There's no really way in the platform, in the VM platform, to reduce that. So that's a little interesting from an assessor perspective, but the tokens are scoped. So you can only get to storage or the key vault or any of the other services like I mentioned. One obscurity I'll say between Azure and AWS is that you can't really use those tokens natively with the Azure CLI. You actually have to put it in an authorization header and make a raw HTTP request to their API, which might make it a little more difficult to use. And then GCP, we've only got version 1 on here, but remember, .1 and beta are pretty much no across the board. So make sure you have those turned off. If you're using version 1, it has SSRF protection. The token timeout by far is the strongest. You'll notice 1 hour, and they're rotating that frequently. Every hour, those things are invalidated. There's no scope. It does require the REST API, but does not have any extraction prevention on it. So that's your summary of the different assessment techniques for really just hardening and monitoring your instance metadata services. So with that, Brandon, I'll pass it back to you, my friend, and you can walk us through the lab environment and some live demos.
Yes, so we are extremely proud of the research we performed for this class and the slides that we've created. But by far, we are most excited to share the lab environment that we've created. So let's talk a little bit about it. We've created a fictional company called Nimbus Immutable, a healthcare provider with a significant presence in the cloud. In SEC510, your mission is to perform a security assessment for this company's infrastructure and its modern web application deployed in each of the 3 major clouds. Nimbus uses many cloud managed services such as IAM, networking, compute, secrets management, storage, serverless functions, and much more. We will cover the common weaknesses in the configuration of each service and how to eliminate them. One of our goals with this class is to cover each provider equally and to ensure that whenever we cover a service in AWS, for example, we are going to show you the same type of service in Azure and GCP. To do this, we have designed Nimbus Immutable's corporate website such that it can be deployed to each provider. When the application starts up, it will detect which environment it is hosted in and will leverage the appropriate cloud managed services accordingly. Instead of thinking of Nimbus Immutable as a single multi-cloud company that leverages each cloud simultaneously, it's better to imagine it as a company that selected each of the providers across 3 parallel dimensions. We will be assessing an AWS, an Azure, and a GCP version of the same application, but the functionality will be identical across each. This way, we can understand firsthand how these cloud services differ across environments. That being said, we will also show how these environments can integrate with each other in a truly multi-cloud environment later in the class. Nimbus's website is a modern single-page application powered by Next.js and React.js. Its functionality includes user authentication, electronic medical record viewing, bill payment, and more. Because you'll be using this application in 3 different environments, and the application looks identical in each of those environments, the application's favicon and the title will match the environment that you are using as shown in this screenshot. Now, Eric here has the CIDR blocks for each of the cloud providers memorized, so this is a little bit extraneous for him, but for me, it's been incredibly useful for when I was working with the environment. So without further ado, I will show off the lab demonstration. So let me pull up my virtual machine here. So you will see that we have an Ubuntu virtual machine right here. And in this virtual machine, it's going to have all of the tools that you need in order to perform an assessment of these cloud applications, including our wiki that is stored in the virtual machine that has all the lab instructions and all the tools you will need to use. So let's first look at the AWS version of the corporate website. So the first thing you should notice is that this is a real website. This is actually on the internet. We are not simulating anything in this class. We have deployed each version of the application to a real cloud account using Terraform. If you're watching this webcast live, feel free to access this IP address over HTTP to see for yourself. Though please don't hack us during the presentation. It would be nice if the presentation went well. For those watching this on the archives though, note that for security reasons, we're going to tear down this infrastructure by the time that you see this. So let's start by logging into one of our accounts. I'm going to log in with an account called Alice. And once I'm logged in, I can either look at my electronic medical records or EMRs, pay my bill, or log out. So let's start by looking at our electronic medical records. So behind the scenes, this application is downloading all of the EMRs and caching them on the cloud virtual machine. You can tell that because the URL, or the path I should say in this case, is /temp/emrs/alice.pdf. So that's an indication that this is a local file path. Now when I click on it, it's going to download that file from the virtual machine. So here we have Alice Cuddy's EMR. And if we look at the file path, we can see that it's trying to access /temp/emrs/alice.pdf. So this means that I could theoretically retrieve other files from this same URL. So what happens if I change alice.pdf with bob.pdf? Well, it turns out that we get an error message. It says that this file does not include Alice in the file name, so therefore I'm not authorized to access this file. So let's actually assess the backend source code that controls this authorization logic. So here is the function that we're calling, this getEMR function. And what is this function actually doing? It's taking a username parameter and a file path parameter. And on line 52, it's checking to see whether or not the file path matches the username. If the file name without the extension matches the username, we are going to call this an authorized request. Otherwise, we are going to give a 401 and we're going to give the error message we saw previously. We downloaded this file with the getFileStream function. So let's take a look at what that function does. So the developers here decided to be a little clever. This application allows the user to download files. Some of these files come from your local file system, and some are going to be downloaded from the internet. So to make their lives easier, they simplified the code and they created a single function for both operations. So if the file name provided in the URL starts with HTTP or HTTPS, it's going to download the file via HTTP. Otherwise, it will read it off of the file system. So now we have two potential application bugs, a local file inclusion vulnerability and an SSRF vulnerability. If we have any flaws in our authorization logic, hackers can do a lot of damage to this application. Now, this version of the application, as mentioned before, is running in AWS. To demonstrate that, you'll see in the title of the page, we have the word AWS, and we have the AWS logo as the favicon. So this means that we could potentially use a server-side request forgery to access the instance metadata service version 1 if it's enabled. So let's craft a request such that our server is going to fetch this endpoint from the locally accessible IP address containing the instance metadata. I prepared this ahead of time, so let me paste this into here. And unfortunately for the attacker, this does not pass our authorization logic because Alice's username does not match security credentials, which is the end of this request. Unfortunately for Nimbus, this functionality is still vulnerable. Can anybody see the issue here? To demonstrate this, I'm going to copy this file name, quote unquote file name. Then I'm going to log out of my account. And it seems that there's a way I can actually create a new account. So what's stopping me from creating an account with the name security credentials? So I'm going to do that. Now I'm going to be logged in. And now I can make the same request as before. And now I am authorized and I am talking directly to the instance metadata service. And as shown in the slides that Eric demonstrated, this is showing the actual name of the IAM role that I'm using for this instance. Now, that's problematic, but it's not nearly as problematic as actually fetching the credentials. Can we do that? Absolutely. We just repeat this attack once more. We log out. We create a new account with SEC510 EC2 as the username, and then we repeat the attack, but instead of going to security credentials, we're going to go to, my apologies, I didn't copy that correctly. We are going to go to security credentials /EC2 And what do you know? Here are our actual credentials for our instance. So we can do anything with these credentials that our virtual machine can do on our behalf for the period of the next 6 hours. So in order to demonstrate this in action, I'm going to show you what an attacker would do with these credentials. To start off, I'm going to show you an unauthenticated terminal session. To prove this to you, I'm going to type AWS S3 LS. So this is to enumerate the S3 buckets in the AWS account. And we'll see here that we don't have any credentials set for this CLI session. And therefore, it doesn't know what account to enumerate the buckets for and what credentials to do it with. So all I have to do to fix this is copy each of these fields, which I'm going to do off screen. Whoops. Let's see. Copying this here. Then I have to copy this one. And then finally, I have to copy this one. And then I can craft some commands that are going to set these credentials for my terminal session, which I'm going to do right here. So now when I press enter, my session will be authenticated. From here, I can run the same command as before and actually enumerate the S3 buckets in this account. So it turns out that we have 3 S3 buckets here. Let's take a look at what each of them contain. So for starters, let's look at the assets bucket. So this doesn't look particularly concerning. These are clearly image files used by the website. Here's some logos. This is probably innocuous. This is probably not a problem. But now we have this EMRs bucket. Let's take a look at what's in there. You can probably guess what's going to be in there. It's everyone's electronic medical record, including Bob's from before. So now I should be able to download that actual file. Let's see that in action. All right, it has now downloaded. Let me ls, and we can see that bob.pdf download failed. Why did download fail? Permission failed in, I'm in the wrong directory, that's why. Let me go to the temp directory to make this a little bit easier on myself. So I'm using this attacker user, and I was in the student directory, so I don't actually have the right to write to that directory. Now I'm in the temp directory, which is world writable, and now we have this file. So if I type ls now, we should see bob.pdf. Awesome. So now I'm going to actually load that file 1 second. Let me try loading it via the File Explorer instead. Something seems to be wrong with that command. So let me go to the temp directory here. How do I go to the temp directory in this UI? Do you know by any chance offhand, Eric, how to get to the temp directory here? I wonder if I can open it in code. That might be easier. Okay, let me try one more thing. I'm going to try moving that file, or I'm just going to download it one more time to my actual home directory. Let's see if this works. Hey, Eric, did I lose connection? Can you still hear me?
Yeah, loud and clear.
It's just been lagging for some reason. Okay, let's hope.
No.
All right, so let me go here. Let me go to the, okay, I'm gonna cheat a little bit and I'm going to copy this from the temporary directory to the student directory. So temp bob.pdf, I'm gonna copy this here. So now this should easily be seen here. Awesome. Okay, there we can see Bob's actual EMR. So funnily enough, the easiest part of this entire demonstration, opening the file, is the one that the demo gods didn't want me to get away with. All of the complicated stuff worked perfectly, unbelievably. So this is where our story could end. But if we go back to the directory listing from before, we actually had something more nefarious. Let's see, right over, where was it? Right over here. There's a third bucket, this corporate bucket. Now, we know that these two buckets, assets and EMRs, they need to be used by the application. But what's this corporate bucket doing here? Is it possible that it contains some secret documents from the corporate headquarters that the application truly has no business processing? Well, if that's the case, potentially we can get some pretty serious dirt on this organization. So I'm going to now try to look at the contents of the corporate bucket. And it looks like there is a memo file. Let's download the memo file. So I'm going to do the same thing to /temp memo.pdf. Okay, and then I'm going to try that command one more time. Okay, instead I'm going to do that little cheat from before. And now, if we look at this memo.pdf, we have this highly confidential file that was a letter from the CEO of Nimbus and Mutable talking to another executive talking about an acquisition. So if this leaked to the public, this could be very damaging to both companies. And I can't express enough how damaging this would be, I think, to any organization if you had a private letter from the CEO just leaked because of one of these compromises. Not quite as bad as 100 million credit card applications being leaked, but still very, very bad. So this lab demonstrates that identity and access management is so critical in the cloud. Now we have two main ways of reducing the damage here. Firstly, we should use the principle of least privilege when it comes to our IAM permissions. Now, without question, this vulnerability was caused by some bad code. We shouldn't deflect from that fact. However, the damage could have been dramatically decreased if we had less permissions associated with the virtual machine. This virtual machine has no business accessing this corporate bucket. It needs to access EMRs, it needs to access assets. That's it. We should not grant it access to our corporate bucket. We will give you many strategies to optimize IAM policy throughout the course in each of the cloud providers. The second mitigation is the one that Eric mentioned earlier. It's to turn off that legacy IMDS v1. We have actually done this in another instance of the application. So if we go to this AWS instance, this one is patched. This one does not have instance metadata, the instance metadata service version 1 enabled. So when I copy this request over, now I actually get a 401 unauthorized response. So unless this application allowed me to make a put request, create that token, and then forward that token to a subsequent request, we are not vulnerable to server-side request forgery. Before we finish this demo, I want to demonstrate that the same kind of attack can be done on Google as well. We talked to you about the hidden instance metadata service version 0.1 or version 1 beta 1, which is a ridiculous name. Supposedly it's going to be shut down in September, but they already delayed this once. So in the meantime, our virtual machine is going to be vulnerable. So here we have the Google version of Nimbus Immutabile. It's the same application, but it's going to be leveraging Google services. So when I go log in with Alice again, and I look at my electronic medical records, instead of downloading from S3, this is now downloading from the Google Cloud Storage Service. And I could do the same trick as before to access the instance metadata version 0.1. So I'm going to log out as Alice, and I'm going to register an account called Acquire. You'll see why in a second. Now, I don't have any EMRs listed here, but if I paste this path in and try to get this /acquire endpoint for the service accounts endpoint of the metadata service, now I have credentials for GCP. I could use this to access the same content, the same types of resources with these credentials as I did with AWS. And the same concept applies for GCP. If I go here to this patched version of GCP and I do the same exact request with the same exact user, I'm going to get a 404 error from Google because this endpoint no longer exists. So that is the demonstration of how we can mitigate the damage done by these legacy IMDS services. So back to the slides. This is a summary of the mitigation strategies. We need to make sure that we are using temporary credentials. Now, we actually got this right from the onset in our environment, but believe it or not, there are some cloud users that allocate permanent credentials to their virtual machines. In that situation, if the attacker compromised the credentials, not only could they use them for 6 hours, they could use them indefinitely until the organization detects the theft of the credentials and deactivates the credentials. In this lab, our credentials were only active for 6 hours, but the damage could still be done in that time period. Beyond that basic protection, you need to have the principle of least privilege applied to your IAM policies. Only grant access to the resources that your application actually needs in order to process the requests made by your consumers. We are going to give you a lot of content in terms of how to lock down these policies. And then finally, we need to turn off those legacy IMDSs. Here's how to do exactly that using Terraform, our infrastructure as code solution that we utilize in this class. Now, you don't need to know Terraform as a prerequisite to take this class. You only need to know how to read the code and understand what the code's doing, because we're going to be giving you so many examples that you can bring back to your organization and use. This is going to turn off the IMDS v1 functionality in AWS. Line 6 keeps the endpoint enabled because our application still needs access to the metadata. It still needs credentials. But line 7 requires that we provide that session token that we get by doing the put request that Eric showed earlier. In addition to that, we set the time to live for the request to a single hop. So if this was compromised, it would not actually make it all the way back to the attacker. The IP packet would expire. Now for Google, it's even simpler. All you need to do is set this one flag, disable legacy endpoints equals true, and now v0.1 and v1 beta 1 is turned off. Unfortunately, they don't do this by default. I'm really not sure why they don't do this for at least new instances, but what do you know? That's what Google does. So in the meantime, make sure if you're using Google tonight, you want to message your developers and tell them, hey, we need to turn this on if we haven't already done this because we are putting ourselves in danger otherwise. So hopefully they'll turn it off permanently when they say they're going to in September. In the meantime, let's do what we can to protect ourselves. Now, finally, I'm going to kick it off to Eric to talk about a couple of the other topics we're going to be covering in SEC510 before we go into Q&A.
Absolutely. Thanks, Brandon. Hopefully you all enjoyed the assessment criteria for the instance metadata services wrapped up within IAM. If we go to our roadmap on the next slide, what we're going to be covering in a very similar fashion. So just that same benchmark across all three clouds with some sort of a hands-on demo and against the Nimbus Immutable website hosted across all three providers is show you how you can build and lock down IAM policies and manage policies. We will also go into networking services, which are covered heavily by the CIS benchmarks. Many of them have traffic monitoring options, private service endpoints where we can actually shield our resources from the outside world to get more private connectivity from your network. Cloud hosted VMs will also be going through virtual network gateways. So how to set up VPNs and even shield resources even further from the internet. As we get into storage, we'll talk about encryption and the various storage services, also in-transit encryption options in the cloud. We'll go into serverless, single sign-on, and that really kind of rounds out our roadmap that we're going to cover on our SEC510 beta course that's coming up here in a little over August 17th. So we've got about 6 weeks or so until we hit that thing, and that's the roadmap we're going to show you. So just to give you some examples, things that we'll go through, the first one really has to do with IAM. And instead of saying, look, you can authenticate users, and here's a basic policy, every section across AWS and Azure and GCP will get into very customized policy documents, such as this GCP policy condition that's using request attribute expressions to actually restrict when maybe an employee can access the cloud. So you can see in this policy, we're saying, look, maybe we don't want them accessing a system after the end of 2020, or maybe you can only access some resource during business hours and so on and so forth. So that's an example of some of the IAM customization that we'll get into. If we take a peek at our next example, we can see that we are doing, kind of a benchmark across all of the different traffic analytics options available inside of the network flow logging resources. So what network data do we have access to? How can we query it and detect maybe malicious traffic patterns within a VPC? So there's a full quarter of a day on those network flow log configurations, where the data goes to, and you actually get to go in and query that information and search for some malware that we maybe have running out in that network. The final example that we've got for you has to do with taking that traffic and getting it moved over into some other cloud account that you've got, or potentially mirroring that data somewhere that you can get access to it from an on-prem perspective. So we'll talk about traffic forwarding, traffic mirroring options, and maybe how you can integrate that with more network forensics tools such as Zeek that we've got on the slide there. So just some examples to get your wheels turning and maybe hopefully get you encouraged to hop in and check us out at SEC510 as we go forward. So Brandon and I will be around to answer questions here for the next, 7 minutes or so. So feel free to queue those up and let us know what your thoughts are.
So we already got quite a few awesome questions. So I'll start with this first question. If not answered later, how do we assess our instances and resources for versions and vulnerabilities in instance metadata? How do we know which versions are available in a resource? Is it simply based on when it's initiated? And that's what's really frustrating, I think, about AWS and GCP, is that they know they have this vulnerability, and yet when you launch a brand new instance here in June of 2020, you will have the legacy versions of the instance metadata service enabled by default. So you actually have to manually change that in order to fix these vulnerabilities. Now, Google claims that on September 30th, they're going to turn off that default instance metadata service. We'll see if they actually do this, because in January, they said they were going to do the same thing. So this is really an issue of your virtual machines. It's not about the individual resources that your virtual machines access. It's a matter of whether or not your virtual machine exposes its credentials in this way. Next question is, when will registration for the class open, or is it open now? I'm happy to announce that it is already open. You can go to this URL on this slide here, sans.org/event/sec510 beta 1 2020 with the dashes in between, and you can sign up for it today. We have some limitations on the beta. You can only have 2 registrants from the same organization, but I promise there will be other betas and full runs of the class in the future. So right now we have some availabilities. We also have quite a few signups. So if you're interested, we'd love to have you, but obviously supply is limited. So hopefully you can join us. I see a couple people have given me advice on how to access the files in the temp directory. I really do appreciate that. It's not a Ubuntu desktop user by any stretch of the means. Then how much is SEC510? You can find all of the finance information on that page. At the end of SEC510, do we get scripts to help automate the hardening of various cloud infrastructure? Absolutely. So we're going to be using infrastructure as code to set up all of our labs, to set up that infrastructure that you saw. All of that was done via automation. Not a single click other than setting up your IAM users to actually do the provisioning is done manually. So you're welcome to take those same scripts that we utilize to harden the infrastructure from day 1 to day 3, and then for the final version of the class, from day 1 to day 5, you can take all of those scripts and integrate them into your environment. Absolutely. That answers the next question. Will SEC510 become a 5-day course in the future? Absolutely. We are running with a 3-day version of the class for August, but we're hoping that we can do a 5-day version of the course either as the next beta or the first non-beta run of the class. That's our goal. Hopefully we'll make it, but we're definitely planning for a 5-day version of the class. We're also planning on creating extended Net Wars challenges for the class in the future as well. But we got to get through the first version of the class first. AWS to convert to version 2. Do you have to restart the machine from AMI image, or can you turn it off and make changes somewhere? I don't think you have to reboot the machine. I think you just turn it off, and I think immediately it takes effect. But I'm not positive offhand. And it's just a setting. It's not a thing that you change in the AMI. It's a meta setting on the EC2 instance itself. Is there a prerequisite for the training or any prior experience? I'm going to kick this off to Eric, because I think he can speak to it better as someone who's worked on multiple classes in this curriculum.
Yeah, so this is intended to be a lighter class. Obviously, I would not recommend if you've never logged into the cloud before. I would highly recommend, we've got SEC488, which is a cloud security essentials course that gets you comfortable with the services and comfortable with the security options in a 5-day format to get you some cloud experience. So far, what we're saying is that should be kind of your baseline, your equivalent level of experience, or take SEC488 as a prereq in order to make sure that when you jump into 510, when we dive straight into IAM and storage, that you already know what that is. And when we talk about metadata service, we'll tell you, kind of how it works, but we're not really going to spend a lot of time introducing a lot of those kind of beginner topics. So I would say it's definitely a 500 level course, and cloud knowledge and some hands-on experience would be preferred.
Certainly, and just to add once more with regards to the infrastructure as code portion of this class. Now, Eric's other class, SEC540, is an amazing class in terms of automating your infrastructure in the cloud and learning about cloud and DevOps. and it involves a lot of writing of infrastructure as code. I definitely recommend that class as well, but it's not a formal prerequisite to this class, because in this class you will be using infrastructure as code without actually writing the infrastructure as code. At no point will you need to write the code. You will simply be using the code to upgrade your environment from one version to another. Now, having some core understanding of what that tool is doing is useful, but it's not a formal prerequisite. So you can take those two classes in either order. But I do recommend both of them, certainly. Okay, does this course cover deploying security tools like Security Onion or other tools and appliances to the cloud? At this current time, no, but we are definitely looking into covering that as well. SEC540 does cover a little bit about that on day 5. We're planning on day 3 to introduce the automated tools for assessing CIS benchmarks in SEC510. So that's one thing we have on our roadmap, but other than that, I don't know of any other third-party mechanism that we're going to be deploying to the cloud in our current version of the class, but we're absolutely interested in learning how we can expand our material to best service the needs of the SANS community. That's a great question. All right, at this point, we are exactly at time, and we've answered all the questions that are currently in the queue. Thank you so much for attending this SANS at Mike presentation for SEC510, Multi-Cloud Security, Assessment and Defense. I've been Brandon Evans, this is Eric Johnson with me, and we're looking forward to teaching this material to the SANS community. So thank you so much. Back to you, Jessica.